Hello everyone, this is Shyam Babu, Assistant Professor, Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Today we are going to discuss about AM demodulators. So before going to discussing the topic of AM demodulators, first of all, what is the demodulation? What is demodulation? To learn about the demodulation, first you need to understand some basic about the modulation. Especially once you can take the AM modulation, here I am taking the two signals. One is, this is the message signal, and here I am taking one more signal, nothing but high frequency signal. It is carrier signal. Therefore, one is message signal, that nothing but our information, and the carrier signal is a high frequency signal. We follow the definition. The high frequency carrier signal is varied according to instantaneous values of the message signal. That's why our information is transferred to a long distance. In terms of power consumption's point of view, also need a carrier signal. Then these two signals are given to the modulator, nothing but AM modulator. The AM modulator examples are switching modulator, square law modulators are examples of the AM modulators. Nothing but once this message signal is given to modulator black and this carrier signal is given to modulator black, then the output should be, this is AM modulator, nothing but amplitude modulation modulators. The output should be, for example, this is the message signal. The amplitude of the carrier signal is varied according to instantaneous values of the message signal. Here the instantaneous values are nothing but amplitude levels. That's why it is called as a amplitude modulation. That means the modulation process needs definitely two signals. One is information and the second one is carrier. The output is a amplitude modulated signal. It is a amplitude modulated signal. Therefore, this is the entire process is called as modulators, AM modulators. The exact opposite of this one, it is nothing but a demodulation. What is that? Remember, here I am taking a demodulator, then the input of the demodulator is nothing but the amplitude modulated signal, nothing but here this is the amplitude modulated signal. Then this amplitude modulated signal is going to the AM demodulators. Then the output should be what information you are transmitting to the signal modulators, that is the output of the demodulator, nothing but a message signal. Therefore, this is the modulator and this is the demodulator. Nothing but with respect to this analysis, we can conclude the demodulator, the input is the modulator output. Especially we are discussing right now AM demodulators. The input of the AM demodulator should be the output of the AM modulator, nothing but amplitude modulated signal. That amplitude modulated signal is given to the input of AM demodulator, then the output should be message signal. Nothing but this is nothing but a demodulation process. Observe here, definition point of view, it is the process by which modulating voltage is recovered from the modulated signal. Okay, what is the input is modulated signal, what is the output is modulating. To get the message signal as the output, when you are giving the input as modulated signal. If you take any demodulation technique, not only amplitude modulation, demodulation process, FM demodulator and PM demodulator, the input to the modulation is, the input to the demodulation is the output of the modulation. That signal is given to the input of the demodulator. But what is the output? The output should be exactly what the information signal you are transmitting from the modulation block. That should be the output of the demodulator block. Okay. Then it is the reverse process of the modulation. It is the reverse process because you are giving the modulated signal as the input of the demodulator. That's why it is called as a reverse process of the modulation. Then the device is used for demodulation or detection is called demodulators. Is called demodulators or detectors. That is same meaning. Detector or demodulators are same. Then simply here, this is the modulated signal, nothing but here I am taking the AM modulated signal. You know very well, this internal line should be a carrier signal. This carrier amplitudes are varying with respect to message signal amplitudes. That's why it is AM modulated signal. This AM modulated signal is given to the demodulator or detector, nothing but AM demodulator or AM detectors. Then observe here, this is the output, this is nothing but demodulated signal. It is equal to our input signal or information signal or message signal. This is the output of the demodulator. This is the output of the demodulator. Then what type of demodulators, AM demodulators we had to generate modulated signal to actual message signal means, for amplitude modulation, the detectors or demodulators can be categorized. I am taking here the two examples. One is the square law detectors and second one is envelope detectors. It is also known as square law demodulator and envelope demodulators. Then discuss step by step. Here, observe very clearly the diagram. Here I am taking the square law device. Square law device is followed with a low pass filter. Actually, just observe the block diagram here. Square law device is followed with a low pass filter. Here the input is AM modulated wave. The output is message signal. Message signal. You know, here the square law device or the square law detector, square law device and the low pass filter. Why I am taking the low pass filter means you very knows about the low pass filter allows only the low frequency signal. You know very well we have the two signals when you are doing the modulation process. One is message signal and second one is carrier signal. In that, the message signal is a low frequency signal and carrier signal is a high frequency signal. But the output of the demodulation process should be a message signal, nothing but it is a low frequency signal. By using low pass filter, the filter allows only the low frequency component. It stops the high frequencies. It stops the high frequency components. Then only the low frequency components is allowable, is passing with the help of low pass filter. Then the output of the low pass filter is simply a message signal. That's why at the end of the demodulator, mainly you are taking the filter should be a low pass filter to get the message signal. It is a low frequency signal. Then observe the working operation with respect to the diagram. Here, the V2 of t, observe here, A into V1 of t plus B into V1 square of t, because we are using the square law device, that's why we are getting the square wave. Then, where V1 of t is the input voltage, nothing but here the voltage should be, you are taking the amplitude modulated signal here, the input is, for example, here this is the carrier. Then V2 of t is A into V1 of t plus B into V1 square of t. We are taking square law device, that's why we are getting the square. Where V1 of t is the input voltage to the detector. We know V1 of t, nothing but this is the AM wave. AM wave, the representation, standard wave equation of the AM, EC into 1 plus M into X of t cos 2 pi FCT. Therefore here it is the carrier and it is the message signal. Because you know the amplitude modulated definition. the amplitude of the carrier, here the EC is the carrier, the amplitude of the carrier is varied according to amplitude levels of the message signal. That's why the equation should be EC into 1 plus m into x of t cos 2 pi fct. Then now substituting the v1 of t into the equation 1, this is the equation 1, then equation should be v2 of t is equal to a into ec 1 plus m into x of t cos 2 pi fct, b into ec square 1 plus m into x of t whole square cos square 2 pi fct. So when you are substituting v1 of t into v2, then I got the equation is like this. But we have the formula cos square theta is equal to 1 plus cos 2 theta by 2. Especially here the cos square 2 pi fct is there. That's why when we are taking 1 by 2, 1 plus cos 2 theta, 2 into 2 pi fct, therefore 4 pi fct according to this one. Substituting this we can get, therefore a into ec 1 plus m into x of t cos 2 pi fct, plus you can substitute this one in the place of cos square 2 pi fct, then the equation should be b into ec square by 2 1 plus 2 into m into x of t plus m square x square of t 1 plus cos 4 pi fct. Here a plus b whole square. That's why the equation is like this. And observe the entire this equation. The equation consists the square terms as well as individual terms also. What is the meaning of square terms? Means it is the high frequency responses. And what is the individual terms? Means comparing that frequency level having the less frequencies. Then observe, with respect to this one, out of these terms, the only desired term is the b ec square m into x of t. What is that? b ec square m into x of t. Remaining all the terms should be comparing this one with the high frequencies. But what is the output of the low pass filter? When you are passing this entire equation through the square law device and then low pass filter, what is the main intention of the low pass filter? It stops the high frequencies. Then it stops the remaining frequency terms. It allows only the low frequency term, that is nothing but b into ec square m into x of t. Hence, this is the desired term exactly by using the low pass filter after the diode. Therefore, v naught of t is nothing but b into ec square m into x of t. Then only, so our first type is over. What is the first one? Square law demodulator. The input of the square law demodulator is amplitude modulated signal is given to the square law device followed with the low pass filter. Then the output signal should be a message signal. It is a low frequency signal. So we detected with the help of square law demodulator. And go for the next one, envelope detectors. Remember, the name it indicates, on the top only when you take in the amplitude modulated signal, this is the amplitude modulated signal, the envelopes are nothing but, this is the envelopes, nothing but at one peak the amplitude should be more, at one peak the amplitude should be less, at one peak again the amplitude should be more, at one peak amplitude should be less. Therefore nothing but the voltage variation should be varying up and down. Therefore, with respect to the change, when you take in the only rather lines with respect to changing the amplitude levels, nothing but envelopes. Then we are observing that envelopes that should be exactly maximum equal to our information signal. Observe here, the envelope demodulator is a simple and very efficient device. For what? To generate a narrow band AM signal. To detection of a narrow band AM signal. A narrow band AM wave is that one in which the carrier frequency FC much higher than compared to the bandwidth. Nothing but the FC should be greater than bandwidth. Then observe the diagram please. Here the input signal should be a amplitude modulated signal is given to the envelope detector circuit diagram. Envelope detector circuit diagram consists mainly here AM wave, this is the standard AM wave equation, nothing but amplitude modulated wave is given to the diode followed with the capacitor as well as the resistor. This is the load resistor. The input to the envelope detector is the amplitude modulated signal. Then the output of the envelope detector should be a message signal, nothing but information signal. How we can get this one? Observe, the standard AM wave is applied to the input of the demodulator, nothing but this is the standard AM wave. You can give to this one. In every positive half cycle of the input, remember, what is that? Every positive cycle of the input, the demodulated diode is forward bias. Especially the same concept we studied in the case of rectifier sections also. When we are given to the positive half cycle of the input, with respect to the diode direction, the diode positive here, nothing but the positive half cycle of the amplitude modulated signal is given to the positive terminal of the diode, nothing but the forward bias happens. The forward biased and charged filter capacitor C. Due to that, whenever the forward bias happens, automatically the charge conduction happens. The conduction happens means the charging is going. The charging is going. Then C is connected to the across the load resistor R to almost peak value of the input voltage. To almost peak value of the input voltage. How much input positive voltage is given? The charge is increasing due with respect to the capacitor. With the help of the capacitor, it is electric storage device. Therefore, it should be charge should be going like this. Then, what is the next one? As soon as the capacitor charges to the peak value, the diode stops conducting. That means the positive half cycle is completed. It reaches to the maximum peak value. What is the next step? The capacitor will now discharge through R between the positive peaks. Nothing but it does not suddenly discharge, it slowly discharge. It slowly discharge. That means as soon as the capacitor charges to the peak value, the diode stop conducting. The capacitor will now discharge through resistor between the positive peaks as shown in figure. Again, the discharging process continues until the next positive half cycle. Until the next positive half cycle is coming. When the input signal becomes greater than the capacitor voltage, the diode conducts and the process repeats. Then observe this one. The charging happens when positive half cycle, and when it reaches to the maximum peak value, it discharges up to when again the positive half cycle present, then again the charging happens, and again the discharge and then charge and discharge like this. This process is completely repeatable. Then observe the shape of this one. Once you can combine this envelopes, then this should be likely a message signal. Then observe here the waveform. This is the internally, this is a carrier. Observe here, first positive half cycle, it can charge up to the peak, and again it can discharge. When it reaches to the peak value, it goes discharging, and again the positive half cycle comes, again it charge, and again discharge, and then charge. When you combine these all charge peak envelopes, then observe the envelope. When you touch the envelopes of the V carrier amplitudes, then it should be exactly the message signal, nothing but our input signal. Therefore, the diode should be on in the case of positive half cycle. The diode should be off in the case of negative voltages or negative half cycles. Then approximate output envelope should be, observe here, this is the likely our information signal. Therefore, with respect to envelope detector, with respect to capacitor, we are concluded we got the envelopes. When you touching the all envelopes, then it should be a message signal. The envelope detector output should be a message signal. Likely we observe the amplitude modulated signal to the diode detector. and then capacitor followed with a load resistor, the output should be a message signal. That means with the help of AM demodulators, we got the output should be a modulating signal. That means the input to the demodulators should be modulated signal, that is the output of the modulation process, AM modulation process. Then output of the AM modulation should be modulated signal, that is nothing but this one. This one is given to the detectors, nothing but square law demodulator, one example for AM demodulator, and envelope detector, it is also one example for AM demodulator. Then the output should be message signal, nothing but a M of T. It is a low frequency signal. Therefore, in this class, we discussed about the AM demodulators. And working operation, everything we discuss, and in the next session we discuss about double sideband suppressed carrier. Amplitude modulation process is completed, demodulation process is completed, and in next coming session we discuss about dsb-sc, nothing but double sideband suppressed carrier. Thank you very much.